What's up? Welcome back to the next video on learning C++. My name is QDS Danny and you guys are watching my channel Croywood. Alright, so in the previous video, as you guys seen that we have done abstract class, and keep in mind a class that holds one of the pure virtual function here. And how you guys gonna write pure virtual function, you guys gonna put a is equal to 0. So when you guys put a virtual functions with a class, if you guys want to create an interface. So now if you guys looking here, virtual void say hello. So keep in mind, you guys don't see this one always. You guys gonna see virtual gonna see animal, for example. You guys gonna see virtual animal, and I'm gonna show you guys. You guys gonna see virtual animal, for example. That's like a constructor. You guys, you're gonna see this way as well. So you guys gonna see virtual, and you guys gonna see the destructor as well. So that's gonna be virtual, and I'm gonna put a tilde here, and you guys gonna see this way as well. So you guys gonna see many form of this virtual, but keep in mind, beside this constructor and destructor, which if you have opportunity I'm gonna explain to you guys in the future videos. But beside this, if you guys want to know what's abstract class is, the abstract class is a class which you guys, if you guys gonna put here virtual void, and whatever function you guys want to put here, say hello or virtual void. So you guys can put a virtual say string, or for example you guys can put any function you guys like. So virtual string ABC, for example. But as soon as you guys gonna put it is equal to 0, it becomes a pure virtual function. As soon as you guys gonna put equal this 0, so this equal to 0 makes it a pure virtual function. So now you guys created interface, and another definition for virtual function is the virtual function which holds an interface. So now this base class is the interface. What's the interface? Interface is something you guys create here. Say you guys create an animal, or you guys gonna put a virtual say for example int number, for example, because you guys wanna see the number but you guys don't know. So that's called interface. When you guys don't know, and you guys gotta create some sort of template, so another programmers come in and use it. So here now you guys create here with the equal to 0, it means that you guys don't wanna explain here in this here. If you guys remember, we used to make say virtual if you guys know, in the previous video we make virtual say string, say something, say something, and you guys could do a lot of things here. You guys could create say your own, say cout animal says, for example, animal says whatever. So now here you guys explaining, you guys not making interface, because you guys explaining, and you guys, this is called polymorphism. So it's something called late binding or dynamic binding. I'm going to show you guys in the future videos what is the dynamic binding or late binding, and that's coming in the future videos. So now you guys creating here dynamic binding or late binding, and keep in mind the compiler now gonna create a table. It's called virtual table. So you guys gonna come here, and for example you guys creating pointer. So at this point the compiler doesn't know anything about this function, about say something, because it's called late binding. Is gonna, if you guys remember, we have done a function overloading that's called early binding. So function overloading, our if you guys know, in past videos we have done our function overloading, that we created many forms of wood. Yeah, so if you guys not sure, so in one we created wood, and another one we created int wood, and in another one we created string wood, for example. So that's called function overloading, and that's early binding. But when you guys come here and create this virtual void, our virtual function is called late binding, and the compiler is gonna come here and gonna wait for you guys what you guys gonna do with all this. And what you guys going to do with all this, it's going to wait for you. So because the compiler at the moment, he doesn't know anything. All it knows that you guys got an abstract class, you guys got an interface, it says say hello, and you guys got a number, whatever number, but it doesn't know anything about these functions at the moment, and which class it belongs to when it comes to compiler compiles. And here, and if you guys look in here, the animals, and it has a pointer, and we have a dog, we have a object of the dog, and we have an object of the puppy, which is the class puppy here, and all of them is saying something about say hello. And here through the pointer we are pointing towards the object Rex, which is belongs to the class dog, and George, which object George, which belongs to class puppy. And if you guys look in here, the last one's object Fluffy, which belongs to class Kate. And now if you guys look in here, the compilers, we are pointing towards these objects, towards this virtual function, pure virtual function, because here we don't have any definition here. Because we are telling C++, look, I want to create an interface, but I don't want to create anything inside it. And here now, in here, we'll say hello, we are creating something. So at the background, at the compiler, so what compilers they do, they create something called virtual table. Virtual table. You guys can put it this one. So this virtual table now creates all of this, and it has a 1, 2, 3, 4, and it's got 4 the table, and all of them is pointing to some of this. So this one's pointing to say hello, this one's also pointing to say hello, this one also, but different objects. So that's how the compilers do at the background. And in the future videos, then we're gonna in the next video, I'm gonna explain to you guys exactly the same ones, and abstract class. So I want you guys to understand the concept of the abstract class and the concept of the pure virtual function. So keep in mind, pure virtual function, if you guys gonna put this one equal to 0, and make sure you guys then come here, and you guys make sure you guys explain everything here. So you guys cannot leave this one say empty. So now here, as soon as you guys do that, the compiler is going to scream at you, because you guys can't do that. You're not allowed. You guys have to put something, because as soon as you guys got an object here, and as soon as you guys got to say you guys got a pointer, and you're pointing to your pointer is pointing to say this pure function, pure virtual function here, then you guys have a trouble, because you guys needs to point to something, and if it's empty, then you guys having a trouble, and if your program is going to crash. So this is the interface, and in a future videos, then we're going to go on dynamic binding or late binding. Sometime you guys here see in the books, or many places they say dynamic binding, they refer to dynamic binding, or sometime you guys are going to see this late binding. So dynamic binding and late binding is the same, and sometime you guys going to see something called early binding. So keep in mind, the late binding is the virtual function. When you guys going to put a polymorphism, comes to late binding. So polymorphism comes to late binding, and function overloading comes to early binding. It comes to early binding. So that's the difference between polymorphism, which is you guys come here and putting virtual. So keep in mind, polymorphism, as I say to you guys at the beginning, if you guys don't understand polymorphism, it's a Greek word. It says something that have many forms. So something that have some word or some function or something that have many forms. So how many forms? Because here now you guys are going to put a virtual function, say hello, and here it has a many forms. It says a lot of things, says function. This is one form, that's another form, and that's another. So you guys can create like 300 of these, no problem. As long as you guys come here and create a virtual, then the C++ gonna wait for you. So the wait for you to point to each of these functions and explain, because all of them functions say hello. Say for example, if it says all of these functions say Google, or say math, or multiplication, or human, or animal, whatever you guys want to do this. So as soon as you guys gonna put it equal to 0, it means you guys then telling the C++, look, I don't want, I'm creating interface, that's a now abstract class, and my abstract class here, I need to put something here. So whoever programmers gonna come here, and as soon as they create something, say same function here, and they create say because you guys got a pointer here, and you guys got a pointing to the object, and you guys now pointing to the, now you guys assigning this object to this pointer, and now you guys pointing towards the say hello, say hello, say hello. But you guys, then the compilers won't allow the programmer to leave it empty, say our function or something on the top, leave it empty. So if you guys create, say assign this one to the pointer, and you guys pointing towards this function, make sure you guys don't leave it empty. So that's the main idea for this interface, and your program is going to be bug free, and it's going to be very good program. So that's it. You guys keep in mind that the pure virtual function, we have equal to 0. That's it. That's and we have something called dynamic or late binding, and we have something called early binding. So early binding, as I explained to you guys, the function overloading, which we've done in the previous videos, and late binding is virtual functions and the abstract classes. So in the next video, I have created a slide, and then we're gonna see the slide. What is abstract class and virtual function, pure virtual functions. You're going to see the same things in my slide. So that slide is for you guys to reinforce the idea of the virtual function and polymorphism, abstract classes, and late binding or early binding. Alright guys, that's it for this video. If you guys have any question or comment, leave in the comment box. Otherwise, I'll see you in the next video, and bye.